Let's have a look at how you can graph some of the more difficult composite inverse trig functions. So we're talking about functions that look something like y equals one of these sorts of things. Now these are actually the more straightforward ones. They get a little bit more tricky once you have, say, a combination of two different ratios here. So perhaps cos here and sine here, or any combination of these. So we're going to have a look at how we would do each of these six, and then how we would do combinations that involve different ratios. Now, firstly, we've already learned that the input to some function, if we call it x, if we put that output from the first function back through the inverse, we get x. In other words, whatever we started from. As we go through two machines where one is the inverse of the other, we get back what we started with. So all of these, notionally, are x. That means if we've got y equals the inverse sine of sine x, then we're thinking it's going to look a little like y equals x. But, and this is a massive but, these graphs all have tricks in them. And the tricks rely on us being able to identify the domain and or the range of each part of the formula. So yes, it's going to be a little like y equals x, but there's going to be a trick there, and we have to consider where these graphs actually exist. So here's, I think, what is the best strategy for these things. I don't want you to memorize what each of these graphs look like. You're much better off knowing some strategies, and then you can apply those strategies freshly every single time you get a question like this. First thing to think is, what values of x are possible? What could I plug in here, or here, or here, or here? Can I put anything I like in? Well, you can see that with these ones, I can take the sine, cos, or tan of anything. X can be anything there. Whereas in these ones here, these graphs, y equals inverse sine x, inverse cos x, or inverse tan x, those graphs have very restricted domains, don't they? So there's only certain x values that I can plug in. So sometimes there will be a limitation on what x can be, and other times there won't. So you've got to think that through. Once you've thought that through, think what values of the part in brackets are possible. What could sine x be? Well, if x can be anything, what are the outputs of that? Oh, they've got to be between 1 and -1. So thinking that through. And here, this will just be the outputs of your basic sine, cos, and tan curves. Here, the outputs will be limited to those restricted domains and restricted ranges associated with these graphs. Lastly, think, okay, now that I've worked out what I'm expecting as an answer for the part in brackets, what's possible? What's the minimum? What's the maximum? What could I get if I take the sine, cos, or tan of that, or the inverse sine, cos, or tan of that? And again, these ones won't have restrictions, these ones will. And that gives us some strange patterns that we'll see in a moment. So let's have a look at each one of these in turn, and we'll try and think through these steps each time. Now I'm actually going to start with the three graphs that were towards the bottom because they're actually slightly easier. So what I'm going to think through here each time is that notionally I've got something that is going to be a bit like y equals x. So think about what that looks like, a tiny little sketch, not so silly to do. Now I'm going to think through, and I'm going to set it out like this. What could x be? What could the inverse sine of x be? And then what could y be? So that I can think about what these things need to be in between. Now, can I plug in any value of x to that? Well, let's think, what does this curve actually look like? It looks like this, doesn't it? And it goes from y values of pi on 2 to minus pi on 2, and x values of 1 to -1, and it stops. It's a restricted domain there, okay? No, that's just a rough sketch, obviously. It's a little dodgy, but that's fine for my purposes. So I can see that x has to be between -1 and 1. So that's my parameters there. Now once I put in a number between -1 and 1 into here, because that's what I'm limited to, what is going to be the answer to that whole section? Well, it's going to be between -pi on 2 and pi on 2, isn't it? So that tells me where I'm sitting now. That means that I can take the sine of anything between here and here. Now think what your normal sine curve looks like. It goes sort of like this. What we're saying then is we're only allowed to put in values between, and I know that my sine curve has pi on 2 here. This is y equals just basic old sine x, which we know well now. I know that I'm only allowed to put in these values from here to take the sine of them. So what are the answers to that? Well, they're between -1 and 1. So that means that these answers here have to be between -1 and 1. That whole thing is between -1 and 1, and that means that y is between -1 and 1. So yes, it's going to look a little like y equals x, but it's limited by -1 and 1. Now I can almost hear you asking, is it x that's limited between these two things, or is it y? Well, it's actually y, because we found that all of this must be between -1 and 1, so y has to be between -1 and 1. So as we go to draw up a simple graph of y equals x, we can only go between 1 and -1, and clearly if x equals y, then this is also 1 and -1, and we have to stop there. So we put a solid endpoint on the ends of the graph. And this is now the graph of y equals the sine of inverse sine x. And you can see my thought process there to figure it out. Now let's graph y equals cos of inverse cos of x. Now again, this is going to be reminiscent of the line y equals x, and I know what that looks like, but I've got to think about where my limitations are. So what values of x can I put in here? In other words, what does this graph look like? Now, a quick sketch of it, I know that it looks something like this. It goes here from 0 to pi, and this is 1, and this is -1. It looks something like that. So the values of x that I can put in, x has to be in between -1 and 1. Now, this isn't any formal notation here. I'm literally just thinking through what it's going to be between. So then once I figure out that I'm only allowed to put those inputs in, what will be the outputs? Well, when I put in anything from -1 to 1, the outputs, or the inverse cos of those numbers, is going to be between 0 and pi. So that's all I'm going to be allowed to put in for this section here. So now think what the graph of y equals cos x looks like. It looks like this, doesn't it? Where we go a full rotation every 2 pi, and here we're working in radians at this point. You could actually be working in degrees and say this is 360. I'm just working in radians. So here I've got 2 pi, this makes this pi, and I've got pi on 2 here. So if I'm only allowed to put in inputs that are between 0 and pi, then I only want these x values from here up to here. So I only want that section of the graph. And so you can see that the outputs, or the y values that I'm going to get, are going to be between -1 and 1. So this graph is going to look just like our graph that we had of for sine of inverse sine of x, and it's going to go from 1 down to -1 on both sections there, and it's going to have a solid circle at the ends. So it looks exactly the same as the sine version. And now for the tan version. Let's do a little bit of this working in our head, but still draw the sketches. So I'm thinking this is a little like the line y equals x, but I first need to consider, what does this graph look like, and can I put anything I like into it? Well, it looks like this, and it's got these horizontal asymptotes here at pi on 2 and minus pi on 2. Okay, so can I put any x value in there that I like? Yep, it goes on in both directions forever. So x can be anything. All right, what about the inverse tan of x? Can it be anything? No, when I put in any value of x, I'm going to get a y value that is between -pi on 2 and pi on 2. It's got to be somewhere between those two. All right, now what will happen when I take one of these values that's somewhere in between there, and I take the tan of it? Well, let's think about what y equals tan x looks like. We know it looks something like this, and it's got its horizontal asymptotes at pi on 2 minus pi on 2. So if I'm putting in x values into this graph that are somewhere between here and here, well, that's fine. What y values can I get out? I can get out any y values in the world that go in both directions. So this means that what I'm actually going to be left with is just simply the graph of y equals x, and it's going to go on in both directions infinitely. So that's that graph there.